Partial pressures, or Dalton's law, is the idea that if you have a gas mixture with different gases in it, then the total pressure is going to be the pressure of each one of the gases that is in there. And so it looks like this. Pressure total is the pressure of each one of the gases that's in the mixture. And this dot, dot, dot means that you can have more than two. You could have 2 gases, 3 gases, 4 gases, as many gases as you want. But the individual pressures of each one of these gases is going to add up to a total. Now, how does this look in reality? So if we take a look at a medical gas tank, I'm going to sketch one out here. And it has a valve and it has a pressure gauge on the top. And this pressure gauge is going to point to whatever the pressure is that's inside the tank. Now, in medical gases, oftentimes you want a mixture of gases. And let's say that you want a mixture of oxygen and nitrogen that's not atmospheric. And so the first thing that you might do is you might put 10.0 ATMs of oxygen in there. And let's say you want not 10 ATMs, but you want about a 50-50 mixture or something like that. Where do you think that the gauge would be now? Well, it would be sitting on 10 atmospheres. It would be on 10 atmospheres. So what if we add in another 15.0 atmospheres of nitrogen? Where do you think that needle's going to go on the pressure gauge? Well, it's going to go from 10 to 25 because you're adding another 15 on top of it, and so our gauge ends up going to 25 atmospheres. And this is for the mixture. Okay, so this is the idea of Dalton's law, is that whatever the pressures of the individual gases, we have 10 atmospheres and we have 15 atmospheres there, the total is going to be whatever they add up to. And so this is actually fairly straightforward. If you have so many atmospheres of one and so many atmospheres of the other, you just add them up. Now, if you wanted to know what you should need, what do you think you should do if you didn't know that the oxygen was 10 atmospheres? What would you do? I mean, you know that you want 25 atmospheres, and you know you have 15 atmospheres. How many more atmospheres of oxygen would you have to add? How would you do that? Well, you would take the 25 and subtract off the 15 to get yourself the 10, to get back to 10.0 ATMs. 25 minus 15 is 10. You do the same thing over here. If I wanted to know what pressure 2 is, but I know what pressure 1 is, I can just subtract off pressure 1 to get pressure 2. That's exactly what we just did here. So it's adding and subtracting. That's what Dalton's law is all about. Now, the one thing that you do have to be careful about when you're doing Dalton's law is that you have to pay attention to units. Now, what do you think? Is this still true? And the answer is no, it's not true. It's not true at all, because 10 millimeters mercury oxygen, you can't just add it directly to 15.0 ATMs nitrogen. You'd have to convert this unit right here to atmospheres, or you have to convert this to millimeters mercury to get your final answer. And so the only thing about Dalton's law that you really have to be careful about that might trip you up is paying attention to the units. Don't just add them up, because this millimeters mercury, you know, the relationship between millimeters mercury and atmospheres is 760 millimeters mercury for every 1 atmosphere. Okay, this is a lot less than an atmosphere, a lot less, because 1 atmosphere would be 760, and that's 10. So with Dalton's law, it's the sum of the pressures that are added up, and the only thing that you really have to be careful about with Dalton's law is making sure that units match up. You have to make sure they match up. What is the total pressure in atmospheres of a gas mixture of 1,448 millimeters mercury nitrogen and 1.20 atmospheres helium? Now this is a Dalton partial pressures problem because we're trying to add two pressures of two different gases to get a total. And so the formula that we're using is P total equals P1 plus P2 plus whatever. And so what I need to be able to do is add up these two pressures to be able to get the total pressure. Now we have to be careful. I notice that that pressure here for nitrogen is millimeters mercury, and it's in atmospheres for helium. Now we can't just add together millimeters mercury and atmospheres. We have to convert one or other to the other. And so what we want is the total pressure in atmospheres. So I believe we're going to have to convert this millimeters mercury into atmospheres before we can add it to the atmospheres over here. So let's do that. The conversion factor between millimeters mercury is 760 millimeters mercury for every atmosphere. So let's go ahead and convert our 1448. And remember, anytime you're using some sort of conversion problem, let's go ahead and set it up so that units cancel. Don't ever think in terms of, do I multiply, do I divide? You don't do that. So we start out with our measured number, which is the 1448 millimeters mercury, and it looks like I have to use this conversion factor, and we have to flip it over so that millimeters mercury ends up on the bottom so they can cancel. And sure enough, millimeters mercury cancels millimeters mercury, and we end up with atmospheres is what we are looking for. So let's go ahead and put that in my calculator. 1448, and that is divided by 760 according to my setup, and that is 1.91 atmospheres. And that is atmospheres of the nitrogen. Now what? Well, we've got our millimeters mercury into atmospheres, and we have atmospheres for helium, so all we need to do to get the pressure total now is to add them up. 1.20 atmospheres helium, and we add it up and we get 3.11 atmospheres mixture. 3.11 atmospheres for the mixture. What is the pressure of nitrogen gas in atmospheres would you need to make a 14.0 atmosphere mixture with 7,420 millimeters mercury? Now this is a partial pressures law calculation, so it is P total equals P1 plus P2 plus however many you got. We have two gases. Now I'm trying to find the pressure of nitrogen gas, which is what I'm trying to find is P2. So to be able to find P2, I'm going to take the P total and subtract off the one that we have. In other words, I'm going to take the total, which is 14 atmospheres, and I got to subtract off this pressure to get that pressure. All right, so this is the equation that we're going to have to use. Now, I want to know what P2 is, what the pressure of the nitrogen gas is. I want to know it in atmospheres. Now, that's the total right there. It's already in atmospheres, but the millimeters mercury is not in atmospheres. So before we can do any subtracting to find out what it is that we need, I'm going to have to convert this 7,420 millimeters mercury into atmospheres. Now the relationship that we have is 760 millimeters mercury for every 1 atmosphere. And so I'm going to set this up as a conversion, because that's what that is. And how do you want to use this? Well, it looks like I'm going to have to flip this over so that millimeters mercury cancels, and so an atmosphere is 760 millimeters mercury. And we'll go ahead and put that in my calculator and see how many atmospheres we have of the oxygen. So 7420 divided by 760 is 9.76. Or 9.8 atmospheres of the O2. So I found the atmospheres of the O2, and so if I want to know how many atmospheres of nitrogen I need to make up 14.0 atmospheres, well, it would be 14.0 atmospheres of the mix minus the 9.8 atmospheres of the oxygen, and that'll give us however much we have of the nitrogen gas we need to put in there. So 14 minus 9.8 gives me 4.2 atmospheres of nitrogen. So if I was to add 9.8 atmospheres in our tank with 4.2 atmospheres of nitrogen, I'll get my 14 atmospheres of my mix. So the amount of nitrogen gas that we need, the pressure is 4.2 atmospheres of nitrogen.